Welcome to Session 9, Absolute Value and Piecewise Reasoning. This lesson strengthens algebra that remains reliable when the numbers or representations become unfamiliar. You will learn to isolate an absolute value expression before creating cases, to translate inside and outside distance conditions correctly, and to select the correct piecewise branch at a boundary. Treat these as connected habits. Keep a pencil ready. We will build a visual model, use a repeatable process, solve a demanding example, diagnose an error, and finish with a checkpoint. Start with this picture. Equal absolute values represent equal distances in opposite directions from a center. Identify the center, then move the stated distance in both directions. For inequalities, inside distance uses an intersection of bounds, while outside distance uses two separate rays. The key distinction is this: isolate an absolute value expression before creating cases. Then connect it to the second goal. Translate inside and outside distance conditions correctly. Correct methods begin with correct interpretation. When a problem looks different, look for the same mathematical structure instead of an identical example. That transfer makes the skill durable. Step 1. Isolate the absolute minus value expression. Identify the object being changed and the requested result. Step 2. Stop if it equals a negative number. Use a separate line so signs, units, and restrictions stay visible. Step 3. For an equation, create two cases. For an inequality, choose inside or outside form. Work efficiently without skipping an operation. Step 4. Check endpoints, branches, and every candidate in the original statement. Whenever possible, verify with evidence independent of the original working. Signal 1 is absolute value equals a positive number. Respond by remembering. Create two equations. Name the response before calculating. Signal 2 is absolute value is less than a radius. In that case, write one compound inside inequality. The form tells you which tool fits. Signal 3 is absolute value is greater than a radius. Remember, write two outside inequalities joined by or. This separates plausible from valid answers. If you cannot name the signal, slow down. Deliberate classification is faster than repairing rushed algebra. Here is the challenge. Solve 2, 3x minus 1, 5 equals 13. Restate the target and identify the most important part of the routine. The first move is add 5 and divide by 2. 3x minus 1 equals 9. This changes the form without changing the meaning. Next, create cases 3x minus 1 equals 9 and 3x minus 1 equals minus 9. Keep the relationship visible and apply the operation to every required term. Now audit distribution, signs, copied values, and restrictions. A brief midpoint check is cheaper than rebuilding the solution. Continue with the third step. The cases give x equals 10 over 3 and x equals 8 over 3. State what the transformed line tells you. Complete the argument. Both candidates make the absolute value equal 9. This is part of the solution, not decoration. The final answer is x equals 10 over 3 or x equals 8 over 3. Compare it with the requested variable, expression, unit, interval, or classification. Verify from another direction, substitute, compare representations, inspect units, or test a boundary. Prove that the result satisfies the original conditions. Try this checkpoint without copying the example. If x minus 4 is less than 3, what interval contains x? Decide which mathematical fact controls the answer. Write one line of reasoning before you commit. A visible decision is easier to inspect and correct. F-focused hint. Stay within 3 units of center 4. Use it to repair your setup rather than guess. An accepted answer is 1 is less than x is less than 7. Explain why it works and name the first step that would expose a common error. The central message is, isolate an absolute value expression before creating cases. Combine it with a discipline to translate inside and outside distance conditions correctly. Finish by remembering to select the correct piecewise branch at a boundary. This turns a calculated result into a justified answer. Reflection, explain and versus, or in absolute minus value inequalities using distance language. Name the error specifically so you can interrupt it next time. Practice one fresh problem within 4 minutes with both branches checked. Keep the work readable, check it independently, and carry the routine forward.